Now, in chapter 5, which is the laws of motion, we will see what are forces. We will see the three laws of motion, or also called Newton's laws of motion. And we will see particles in equilibrium, solve some problems on that. And then we'll see what is friction and how we can include that in motion. So the first thing is, what is a force? So a force can be defined as something that can alter the state of motion of an object. So if we have an object here, okay, let's write that first. Force can alter or change the state of motion of an object, which means that if the object is stationary, a force can cause it to start moving. If an object is moving, a force can cause it to go faster, or it can cause it to slow down and stop. So whatever is a state of motion, it can change that state of motion. So if you have an object here, and let's say a table or something, you can apply a force from this direction. You can push it and cause it to start moving towards the right. Or you could even pull it from the right instead of pushing it, and that would also do the same thing. So a force could be a push, or it could be a pull. Now, both of these forces are actually acting, well, they are actually, whatever is causing the force, the object, the person who's pushing it, is actually physically touching the table, or maybe tying a rope and then pulling the table. So these kind of forces are called contact forces, where the agent applying the force is in physical contact. The other kind of force is what we call a field force. And this is the case where there is no apparent contact between whatever is creating the force and the object on which the force is acting. So for example, if you have a magnetism, so we have two magnets or magnetic forces, then that is a field force. Now here I have two magnets, and when one comes close to the other, it just pulls it in without any apparent or at least invisible thing in between. It has the effect of pulling it, or it could even push it, push it away. So magnetism is a field force because it acts over a distance. It creates a magnetic field that affects other magnets. Other field forces are gravity. So for example, the Earth is going around the sun because of the gravitational pull that the sun exerts on the Earth. And third is electrical forces. So positive charges repel each other and negative charges repel each other, and opposite charges attract each other. So we have electric forces, gravity, and magnetic forces. These are all field forces, and they act over a distance. And the contact forces need to actually physically touch the object. Now, a force is a vector. That means when adding forces, we have to add them as vectors and not as numbers. As an example, let's suppose that we have an object over here, and there's a force of, let's say, 10 newtons in the right direction towards the right, which if we make the x here and y here, this would be 10I. F1 would be 10I, and the units are newtons, and we'll just look at what we mean by a newton. That's a unit of force. So when you pull it this way, it's going to create some kind of motion. Now here's another force, acting on the same mass. F1 is removed, and we have another force, F2, which is, let's say, 5I newtons. So this is pulling it to the right with a smaller force. Now, if both of them act on this object at the same time, or we could have F1 here and F2 here. They're both pulling towards the right, and so the F, or the resultant, becomes F1 plus F2 becomes 10I plus 5I becomes 15I newtons. However, if the forces were acting like this, F1 this way and F2 this way, then they won't add up to 15 newtons because they're opposing each other, and so the resultant would be 10I plus, this force is now negative 5I, and so that would be a negative 5I, which is 10 minus 5, which gives us 5 newtons towards the right, because this was 10 units and this one was 5 units, so the result is towards the right. Now, if the two forces are not in X and Y, they are like one force pulling this way, this was the 10 newtons, let's say, or F1, and the other is perpendicular to it, and now it's going to be 5J. And then we can add them in several different ways. The resultant, is it going to move towards the right just because this force is bigger than this? Or is it this force going to have an effect? And it will. The two forces will add up to create a resultant force, and the resultant force is going to be F1 plus F2, which is 5J, and that is the resultant force, which is a complete description of the resultant force. Now, you would or you may like to find what is the magnitude of the resultant force, and that would be F1 square plus F2 square root. That's 125, so it's the square root of 125, comes out to 11.2 newtons. And if we try to find the angle at which that force is acting, we can consider this force and use the parallelogram rule, draw two parallel lines, and the resultant would be in this direction. So the theta, which is this angle, would be tangent inverse of the y of this triangle, which is 5 over the base. So tangent of 1 by 2 is 26.6 degrees. So the resultant force can be written either as this or as this. But don't just say that the resultant is 11.2 newtons, because it is a force, and a force must have a magnitude and a direction. So you would say it's 11.2 newtons at 26.6 degrees. This is something that's very important. It's a very common mistake. People just add vectors as numbers. You just add 10 and 5 and make it a 15. It would not be 15. It could be anything from 5 up to 15 in terms of magnitude. It could have any value in between, depending on the angles. Now, we've done vectors, but this would be like a short revision. So if you have F1 in, for example, this direction, which would be written as F1 x component in the I plus F1 y in the j. So this would be F1 x, and this would be F1 y. And let's say the other force is this way. This is F2. So F2 would be written as f2xi and f2yj, and this would be the f2x, and this would be the f2y. Well, this being negative, we could put it like, put a negative here. And then the resultant, which is f1 plus f2, would be f1xi plus f1yj plus f2xi plus f2yj. In this case, yeah, we need to remember that there's a negative here. So the I can only add with an I, and the j can only add with a j. And that gives us f1x minus f2x I and f1y plus f2y j, and that would be the resultant. And graphically, well, we can make a parallelogram and see that it's going to go in some direction. Okay, so that ends what we like to talk about forces, and now we go to the next topic.